Today's lesson, the product rule, the next of our shortcut type rules for derivatives. Suppose we start with a function, we'll call it h of x, and we'll say it's the product of two functions multiplied together. By definition, the derivative is take the derivative of the first piece times the second piece plus the derivative of the second piece times the first piece. This will work very, very effectively well throughout. Sometimes it makes sense to do products a slightly different way, but for the purposes of today's lesson, we're just going to do absolutely everything by this rule. So I'm going to start with a ridiculous example. We would never actually do this one, but I just want to show you that it does in fact work. So suppose my two functions are x cubed and x to the 8. The derivative of the first, 3x squared, times x to the 8, plus the derivative of the second, 8x to the 7, times x cubed, the first. We can simplify these and put them together. Now, realistically, we could have just multiplied x cubed times x to the 8, gotten x to the 11, and taken the derivative of that. I just wanted to use this example to demonstrate that, in fact, the product rule does follow a series of steps which does get us to the final answer. My next example, I've got two binomials. Rather than multiplying them together, I'm going to take the derivative of the first, 3x squared plus 0, which is just 3x squared, times the second plus derivative of the second, 5x to the 4, times the first. Now I multiply it all out, collect like terms, and we're done. Next example. Our function is 5 root x multiplied by x cubed minus 4x squared. Remember that root x is the same as x to the power of a half. So, derivative of the first. Bring down the 1/2, times it by 5 is 5/2. Subtract 1 from the 1/2 gives me the negative 1/2. Times the second plus derivative of the second, 3x squared minus 8x, times the first. And now I'm going to go through a little bit of fancy cleaning it up. I'm multiplying the 5/2 x to the negative 1/2 into the first bracket. Same thing with the second set. I'm tidying things up so that we can see that by finding common denominators and adding things together, I've actually only got two terms here. My x to the 5/2 and my x to the 3/2. X to the 5/2 is the same thing as the square root of x to the 5. X to the 3/2, the same thing as the square root of x cubed. So I can write them out as I have done. For my next example, again, just pay careful attention to the pattern. Derivative of the first, 6x plus 2, times the second plus derivative of the second, 12x squared, times the first. Clean everything up. I'm skipping some steps as I'm doing this. Collect like terms. And hopefully we're quite satisfied with our answer. It's the same as in the back of the book. Homework for this section, we're going to be on page 92. And please do question numbers 1, 2, 3, and 6. Number 1 and 2, just the odd letters. Number 3, just A and D. And number 6, well, have fun. Enjoy your day.